All right, geometry, here's AMI day 11. You'll have four problems, I think, with parallel lines cut by a transversal. So we're going to talk about that today. We had some angle pairs that we could form whenever we have parallel lines and a transversal, fancy enough. The first one that we had were corresponding angles. So those were the angles that if I were to take these four on top and pick them up and put them on top of the four on the bottom, then they would correspond or match up to one another. So 1, if I were to pick these up, put them on top of these bottom four, 1 corresponds to 5, 2 corresponds to 6, 3 to 7, and 4 corresponds to 8. So one of the great things about corresponding angles is they're congruent. They have the same angle measure. So if I took angle 2 and angle 6 and I were to have, say, an expression that represented them, I could set them equal to one another and figure out what that angle measure is. Okay, so we're going to do that now. We're going to say angle 2 up here is no longer angle 2, it's 23x minus 5. And its corresponding angle at 6 is no longer 6, it's 21x plus 5. Okay, so I just have expressions now instead of those numbers. It doesn't change the fact that they're still corresponding, still congruent, and still equal to one another. So all I have to do is take these expressions and set them equal to one another. So 23x minus 5 is going to be equal to 21x plus 5. Okay, so once you have it like this is solving just a normal equation. I'm going to get all of my x's to one side. I'm going to get all of my regular numbers. Can't remember what the name for them are. Been out of school for a little bit. I don't know if you knew that or not. To the other side. So I'm going to start off and I'm going to bring all my x's over here to the left. So I'm going to subtract 21x from both sides. Okay, 23x minus 21x gives me a 2x minus 5 equals a positive 5. Now I need to get that negative 5 over there, so I'm going to add 5 to both sides. And 2x is 10. And to find out what just an x is, I'm going to divide both sides by 2. And x ends up being 5. So now I can take that 5 and I can substitute it back into my expressions that I have up here. So, and it doesn't matter which one you choose. They're congruent, so it would be the same. We'll check it to make sure. All right, up here on top, I've got 23 times 5 minus 5. And, okay, sorry about that. I was looking for my phone so I could use my calculator, but it turns out my phone is what's recording right now. So, I have my calculator. I'm going to type that in, 23 times 5 minus 5. And I get 110 degrees. So I know it may not look like it because that looks like an acute angle, but you know not to trust my drawings. They're not ever good. So that's 110 degrees. Even though it doesn't look like it, my expression says it is. So I'm going to take that and I'm going to also sub it in down here at the bottom. See if I get the same thing. I should get the same thing. So 21 times 5 plus 5. And I do. Who knew? 110 degrees. So those are corresponding angles. Okay, our next angle pair we're going to look at are vertical angles. Vertical angles are those ones we talked about. They're made by intersecting lines, and it's almost like they're across from one another. They share a vertex, but they don't share a side. In our diagram here, our vertical angles are 1 and 4. They are formed by those intersecting lines. They share a vertex, but they don't share sides. So 1 and 4 are vertical, 2 and 3, 5 and 8, and then 6 and 7. Those are all of the vertical angle pairs in here. So we're going to do kind of the same thing we did before. We're going to take some of these numbers out, put in some expressions, and see what we come up with. So I'm going to start off and let's see. I'm going to do 6 and 7. 6 and 7 are a nice pair of vertical angles. 6 is going to be 12x plus 17. And 7 down there is 14x minus 1. Okay, so we know about vertical angles. They are also congruent, which means we can do kind of the same thing that we did with corresponding angles. We can just take the expressions that represent their measures and we can set them equal to one another. So 14x minus 1 is equal to 12x plus 17. Okay? And so you're done with the hard part. Now you have to do is solve the equation. I'm going to get all my x's over to the left, so I'm going to subtract 12x from both sides and get 2x minus 1 equals 17. I need to get rid of that 1 over here, so I'm going to add it to both sides. So 2x equals 18, and then divide by 2 to get x by itself. Okay, it turns out that x is 9. I'm going to take that and substitute it back in my expressions that I already have for my vertical angles. I really only have to do one because they are congruent, but we're going to do both of them just to make sure we're doing the work correctly. So I'm going to take this 12x plus 17 and I'm going to substitute in a 9 for it. So 12 times 9 plus 17. I should know that. I don't. We get 125 degrees for what used to be angle 6. Okay? I'm going to check it in this second expression just to make sure I'm doing what I need to do, or that I know what I'm doing. 14 times 9 minus 1. 14 times 9 minus 1 is also 125. So that's how we find angle measures for vertical angles. Okay, so last but not least, let's look at same side interior angles. Okay, same side means that they are on the same side of the transversal. So this line here is my transversal. They'll be on the same side. And interior means it's going to be in between my parallel lines. Okay, so same side interior are like 4 and 6. They're on the same side of the transversal and inside my parallel lines. 3 and 5 are also same side interior. So let's put in some expressions. I'm going to use 3 and 5 because you know my affinity for odd numbers. 3 and 5. I'm going to put in some expressions. 3 is going to be 20x plus 5. And then 5 down there is going to be 24x minus 1. Okay, so what we need to know about same side interior angles is that they are supplementary. Okay, that's going back a little ways. I have to reach back. Supplementary. So supplementary. That means my angles add up to 180 degrees. There's a space there. Okay, so these two angles are going to have to add up to 180 degrees. So I can't set them equal to one another. They are not congruent. Okay, what they are is that when they're added together, they give me 180 degrees. So 20x plus 5, there's my first expression, plus 24x minus 1, and I've added those together and set it equal to 180 degrees. Okay, I'm going to start combining like terms. So 20x and 24x, those are like terms. I'm going to add those together and I get 44x. My 5 minus 1. 5 minus 1 gives me 4. And that equals 180. I'm going to subtract that 4 from both sides. And 44x equals 176. Now I have to divide by 44. And I believe that'll go in there 4 times. I'm gonna double check. 176 divided by 44. Yep, 4 times. Okay, so x is 4. Now whenever I sub this back in up here, I'm actually gonna have to sub it in for both expressions. Since they aren't congruent, they're gonna be 2 separate measures. So I'm gonna have to do this both times. This isn't just a check. I actually have to do that. So x is 4, 20 times 4 plus 5. 20 times 4 is 80. 80 plus 5 is 85. So this one right here is 85 degrees. 24 times 5 minus 1. 4 times 5 minus 1 times 5. Good grief. Losing it. It's 4. It's 24 times 4. 24 times 4 minus 1. 95. Okay, so this one is 95 degrees. So I know that these two angles, when they're added together, should give me 180. So if I take 95 degrees plus 85 degrees, I get 180 degrees. So that's how I check it. I'm going to take these two angles, add them together, make sure that I'm getting 180. So angle number 3 up there, 85 degrees. Angle number 5 right here, 95 degrees.